And as next speaker, we have my friend André from Paris, from JEDI, Joint European Disruptive Initiative, where we also refer a lot to these topics because the whole JEDI movement is about deep tech in Europe and how we could foster innovation and so on. So André, are you ready?
Thanks a lot.
Thank you very much.
I'll head out. Have a nice one. Thank you for having me.
Yes, hello, Michael.
So the floor is yours.
Hope you can all hear me. For me, it's a premiere because I'm not in my office and I'm using a Starlink connection to do a Zoom call. So we will experience firsthand how good the service is of our good friend Elon Musk. That's all for European technological sovereignty. So I'm trying to share my slides here, and if I'm not able to do that, I would ask Noemi if you could help me sharing the slides, because apparently it's not working for a reason I don't know.
Let me know if it doesn't work. I'm ready.
Yes, please. Can you share the slide?
Yes, of course.
And I will just say next to go to the next one.
Oh, ich sehe jetzt scheiße. Ich sehe nicht mein Telefon.
Okay, I'm going to talk, so if you can go back to slide 1, I'm going to speak today quickly about one of the areas that we at JEDI are tackling related to future of democracies. I think it's very much related to the previous panel, so that's perfect. So next. To give you a very short explanation what JEDI is, we are a foundation. We do something that normally governments should do at national level or at European Union level, which is to launch grand challenges on topics which are too risky or too long-term for the private sectors, but that can be game changers, the so-called moonshots. We support very much the national initiatives that are being, or the EU initiatives that are happening currently, but we also see how much they are entangled in a lot of bureaucracy. And we think it's really critical that we in Europe don't wait for the Chinese and the Americans, be it the states or be it the tech giants, to move forward. And we are very excited about what's happening. So it's a very positive movement. It's saying that science and technology is central in our century, but it's not much more than just economics. It's at the center of our societies. Next. You can see the whole area of areas in which we are active. We don't do like DARPA in the US defense. We focus on large societal goals. I think we created this very concrete mission approach that a lot of people are talking about, but remains very fluffy. We try to be very concrete, that within these societal missions, we try to identify the very precise technological or scientific bottlenecks on which putting together the best brains throughout Europe and the world can help solve and move forward our society. So I'm going to focus specifically on future of democracies and how much technology can help. Next. So we try to do that humanistic inside. We see a lot about technology, and we saw the debate about drones just now, that it can be seen, rightly so, as a threat to democracies. We try to imagine how technological advancement can actually embed humanistic and democratic values within the technologies we develop. So this humanistic inside approach. So let me give you 3 examples of challenges on which we are working on. Next. The first one is about face recognition. It's a hot debate. There are the proponents of a complete ban, those who think that it has some value. I tend to say that it's not completely to be removed, because let's not forget that in this digital age, identity usurpation, identity theft will be increasingly important and catastrophic for the person concerned. And this will touch and affect probably the less favored parts of the population. So face recognition is not all that bad. On the other side, we don't want authoritarian surveillance states. So one of the challenges that we are thinking of is, could we develop face recognition without a centralized database, distributed? And if you remember, the very initial idea of the internet was very close to that, was, can we do a communication network without a center that would make it very resilient? And that created the whole packet approach and IP protocol. That was actually ARPANET and a creation of DARPA. We also think about the challenge where we could not reverse engineer to individual data. So this would combine the best of two worlds, which is on one side, creating a very solid identification measure in this digital world. On the other side, not having these databases that can be either hacked or used for purposes we don't want, as we can see in authoritarian and dictatorships currently. Next slide. We're also working on this topic. I mean, there is this buzzword about explainable AI. We prefer the word causality. So can we understand what is the cause that created that result? And we are obviously working on several areas. One of them, we are very supportive of the initiative of the German AI Association, the KI-Verband, on creating large AI models, also on the European side. Our focus on the scientific part will be very specifically on how much these massive, with hundreds of billions of data sets, and we're going to pass the threshold of 1 trillion very soon, can be actually manipulated, and how can we put a detector of this manipulation? This is increasingly difficult the larger the data model is. We also believe that if we want to trust in these algorithms and these systems, we need to be very clear about the competency, what this model can and cannot do. And often this is not clear for the user. So this competency awareness, trying to put a very quantitative metric to it, is really a challenge today and a frontier that we're trying to tackle. We also believe in the concept of federated learning. So we are going to launch a challenge specific on that, as how can we use several databases, heterogeneous data, but considering it as one big database on which we can run our large deep learning algorithms, for example, without having necessarily to merge them. And we could see during the Corona crisis how much this has been a hindering to actually using big data, because we had, rightly so, the privacy concerns of these massive databases. And last but not least, this is a bit more technical, is this whole concept of homomorphic encryption. Can you run large data models without going back to the individual data and having that really by design, and not just putting different layers that as protection layers, as we know, that can be always hacked. And this has to do with very basic and very complicated mathematical algebra. It's all about Boolean mathematics. And so it's also another exciting challenge. And last but not least, the third big area, next slide, is all about cognitive manipulation. We heard about deep fakes. It's incredible to see, and this is really a call for action, that everybody gets excited. The Bundestag, the European Commission, the French government, about deep fakes. It was the topic of Emmanuel Macron's speech at the last Munich Security Conference, where he attended 2 years ago. And at the end of the day, nobody's really putting a lot of efforts. You have a few efforts being done at the TU Munich, but the only ones who are really putting massive money in that is Facebook with $10 million research programs. So we are going to launch a challenge, and it's a call for all of us of those who want to support us, because we don't want Facebook to be the ministry of truth that will be able to say tomorrow what is a correct video and what is a deep video. We obviously have the rise of deep text, and the third challenge that we're thinking on in this area is about social media without echo chamber. Obviously, this is a concept. This is complicated, because this is at the core of the business model of social medias. Is how can we do dissemination of information, which is key for our society, opinions to be formed, without the amplification effect, which, as everybody knows, is different according to the positive or negative aspect of the information. So next slide, and that's going to be my conclusion slide. It's all about doing things. Today is May the 4th, so thank you, Michael, to invite us at this very special day where we celebrate 24 months of JEDI. And next slide, if you want to join us, if you want to join these challenges as a participant, if you want to join us as a strategic partner, if you just want to be informed about how Europe tries to regain its technological sovereignty and leadership, feel free to engage, and happy to answer a few questions.
Yes. Thank you very much. It was an excellent time management. Thank you also for the presentation and for the insights. Let me, coming back to one of your slides, you mentioned the use case of face recognition, right? And you said, yes, to face recognition, but not linked or related to a centralized database, which I think it's a very good approach with a flow, which is a lack of data, right? So the beauty of a centralized database is you have a lot of data. So if you decentralize this approach, you will end up having less data and losing in precision. Am I right in this approach or in this statement?
This is obviously the current state of the art. The challenge actually goes way beyond, because if you think about how today face recognition and simply CCTV systems are organized. They're organized with a camera, with data links that carry always bigger amounts of data. You have a lot of energy consumption, which is, and then you have a centralized database. The big question we are asking is whether we can actually implement at the level of the camera the capacity to do face recognition. Obviously, today there is no idea, and the whole point about JEDI is not to be prescriptive on how to achieve the goal, but to clearly state a goal like that. And what would it achieve, which is the actual problem. The problem is hacking a single camera in, I don't know, in Berlin is not an issue, because that would be limited to the people who are passing in front of this camera. What is an issue, a societal and a privacy issue for all of us, is if you have access to all the cameras. I mean, think about the Jason Bourne.
We lost you.
It has to be, this challenge is obviously linked to this concept of small data AI. Can we develop AI models which don't require millions and billions of labelized data sets? Obviously, it's a frontier.
Yeah. Let me ask you a very last question, because you have been talking about Facebook, and you said we don't want Facebook to be the ministry of truth or Amazon. I agree with you. Unfortunately, those big companies possess a lot or large data sets, right? So that's why whatever they predict, whatever they model, yeah, they have a higher degree of precision, right? That's why they are closer to the truth and to predicting customer behavior. Do we agree on that?
No, absolutely. And let me be very clear. Our approach at JEDI is not to be against. Is not a strategy. Europe is a bit too much playing on defense. We need to shape the future. And that answers your question, is customer behaviors are changing very quickly. So if this data set is not updated very regularly, it will relatively soon become less relevant. So the point here is not to try to create another Google or another Amazon, is to invent a way we are going to capture the data in the future. And we think, I mean, look, we're using Zoom. Zoom did not exist 5 years ago. Now it's worth twice the whole value of all airlines in the world. Agreed, airlines are not worth anymore so much as they used to, but that's the beauty of technology, is that you can reshuffle the cards. So it's all about having this proactive approach, and I think that applies to data sets too. But clearly the challenge is high, but with all the collective intelligence we have in Europe, there's absolutely no reason we cannot achieve this.
Nice to hear that. Thank you very much for your time and for the great presentation. Have a nice time. Bye.
Thanks to all. Have a great one. Bye.
So now